Okay, so hello everyone. Today we'll be focusing on GLM5. GLM5 has been a very significant improvement over their GLM 5.1. 5.2 is an amazing model, and I think we should all understand exactly how they are operating and what they are doing. So let's go through it. I'll be sharing my screen. Okay. Mm, So as you can see, this is the book, and this is how it is covering the syllabus. So we'll first start with the bigger picture. We'll start with vibe coding to agentic engineering. Vibe coding, a human prompt an AI model, human prompts an AI model to write code. In agentic engineering, a AI agent writes the code themselves. They plan, implement, and iterate. So here is the difference. We'll have to plan it, implement it, and then iterate over it. This chapter is the map of whole territory. We will not derive a single equation here. Instead, we build the vocabulary and mental model you need so that in every later chapter, we can drive straight into a mechanism without stopping to explain what the word means. By the end, you should be able to say in one breath what GLM5 is, what problem it solves, and how it was built, why anyone cares. The central metaphor, vibe coding to agentic engineering. The title of the source paper is a thesis statement from vibe coding to agentic engineering. Understanding those two phases is understanding the paper's ambition. Vibe coding is the mode in AI assisted programming most people experience first. A human sits in a loop at every step. You type a prompt, write me a function that parses the CSV, and the model emits the code. You read it, you run it, and you notice it's wrong. You prompt again. The human is the planner, the tester, the integrator, and the one who decides when the task is done. The model is a very fast autocomplete. It has no persistent goal. It reacts to each prompt in isolation. So this is an important thing. There is no persistent goal. It is simply reacting. Okay. Um, Agentic engineering moves the loop inside the model. Now the AI is handed a goal, fix this bug, implement this feature across the code base, run this business for a simulated year, and it is expected to plan, break the goal into steps, implement, write and edit code, call tools, run command, and iterate. Read the results of its own action, notice failure, and correct itself over a long sequence of steps, with often with no human intervention until the end. The difference is not cosmetic. It is the difference between a calculator and an accountant. A calculator is correct on each keystroke, but upholds no plan. An accountant carries a goal across hours of work, recovers from mistake, and decides for themselves what to do next. The paper's entire program, the architecture, the data, the reinforcement learning pipeline exists to turn a model from the former into a latter. So in vibe coding, we can see there's a human in the loop. The human, it sends prompt to the model, codes test, and integrates, decides done. So model is a fast autocomplete. There's no memory of the goal. Now let's talk about agentic engineering. Agentic engineering, there's a loop inside the model. Human just defines a goal, the model plans it, acts on it, observes, and it does a self correction. The phase you'll see for length of this loop is long horizon. So we call this long horizon task. A long horizon task is one that requires many dependent steps where each action changes the state the next action sees. Writing code for human, running a business over a stipulated year, navigating a code base of years of tens of thousands of file. Okay. Long horizon competence is the property that separates a real agent from a chatbot, and it is a property GLM5 is most proud of. Okay. The art triad, agentic reasoning coding. GLM5 inherits a frame from its predecessor, GLM 4.5. A single model should be strong at three intertwined capability cluster, abbreviated as ARC, agentic. So the ability to operate as an autonomous agent. The use tool, search the web, call an API, run an shell command to take multi-step action in an environment, to read the environment's feedback, and to keep a coherent plan across a long interaction. This is the do things in the world access. Okay. To take multi-step action in an environment. Okay. Okay. Read the feedback and to keep a coherent plan across a long intersection, and keep coherent plan across a long interaction. This is the do things in the world access. Reasoning, the ability to think through hard problem step by step before answering. Mathematics, science, logic, competitive programming. This is the think careful access, and it is closely tied to the model's ability to produce a chain of intermediate thinking token before committing to an answer. Coding, the ability to read, write, debug, and modify software. This is the capability with the most direct economic value, and the one the paper treats as providing ultimate proving ground, because real coding requires both reasoning to figure out what's wrong and agentic skill to navigate files, run test, and iterate. Why bundle them into one model rather than train three specialists? Because they reinforce one another. Good coding needs reasoning, good agency needs both, okay? And training model on three at once, as we'll see in the post training chapter. Oh, okay. So we need to train model on these three skills, which is first is agentic, second is reasoning, and third will be coding. So why we bundle them in one model rather than train three specialists? Because they reinforce one another. Good coding needs reasoning, good agency needs both, and training the model on all three at once. As we'll see in the post training chapter, produces a generalist, okay, that is better at each than a narrow specialist would be. Mhm. So we have a generalist that is better at each than a narrow specialist. Mm. The recurring risk which the paper spent real effort defeating is catastrophic forgetting. Acha. So there is a problem with catastrophic forgetting as well. Catastrophic forgetting. Training hard on one axis can erode the other. Hold that term. It returns in chapter 11. Mhm. GLM 5 at a glance. Here is one paragraph identity card with every term defined as it appears. GLM 5 is an open weight model. Its trained parameters are publicly released under a permissive license, so anyone can download and run it. It is a contrary to proprietary model, okay, whose weights are kept private and accessed only through an API. It is a mixture of expert model. Instead of every input passing through one enormous dense network, the model contains many small expert subnetwork and a router that sends each token to only a few of them. So the model can be huge in total while only activating a fraction per token. JLM5 has 744 billion total parameters, but only 40 billion active per token. It uses DSA, which is deep six sparse attention, and attention mechanism that looks at only the most relevant past token instead of all of them. Mhm. So DSA is an attention mechanism that looks at the most relevant past tokens instead of all of them. To make very long context affordable, it was trained on 28 trillion token. Wow. We will unpack MOE in chapter 2, DSA across chapter 3 5. For now, many experts, few active, and attention that skips irrelevant token are enough. Okay. So lineage and where GLM 5.2 sits. GLM 5 is a point on a fast moving line. GLM 4.5 introduced the arc framing and MOE backbone. The paper constantly compare against it as the previous generation is an interim release through used throughout as a strong internal baseline in several places as a teacher or difficulty filter. Okay. The subject of this paper roughly doubles the model, adopts DSA, and overhauls the reinforcement learning stack. The focus of our incremental material is a latter point release built on GLM 5. Its headline changes uh, its headline changes is a 1 million token context window made affordable by index share, a cross layer index reuse. Okay, so there's something called index share. You should do something about this thing. So its major feature is index share. It is a cross layer index reuse trick. Okay, and it is published separately as index cache paper. Okay, we'll devote chapter 5 to it, which is okay, index cache. We mean these long context and inference efficiency additional layer on the top of everything GLM5 already is. A note on naming. There's no standard standalone GLM 5.2 research paper. GLM 5.2 is documented through model card plus index share paper, index cache paper. This is exactly why this book uses the full GLM5 report as its spine and folds GLM 5.2 in where it differs. The headline results in plain terms. The paper opens a barrage of benchmark when you do not need to memorize the numbers. Okay. Chapter 15 and 16 dissect each benchmark. But you should understand what kind of claim each figure is making. Figure 1. The first 8 arc GLM5 is compared against 4 frontier models. Okay. Across 8 tasks spanning agentic reasoning and coding work. The claim GLM5 averages about 20% better than the prior 4.7. Lands comparable to Opus 4.5 and GLM5 and GPT 5.2 and ahead of Gemini 3 Pro. Mm. Effort reasoning setting, a reminder that the same model can run at different thinking budget, a theme that returns when we discuss turn level thinking. Oh, so now there's something called turn level thinking. Artificial Intelligence Index V4.0. This is a composer score aggregating 10 independent evaluation into a single number. GLM5 scores 50 up from JLM 4.7's 42 and it is the first open weight model to reach 50. Open weight leader in the specific cron we claimed. LM Arena from UC Berkeley is not a okay among the open weight and coding arena on par with Opus 4.5 and Gemini 3 Pro. Long horizon coherence to test probe whether the model stay coherent over very long task. Vending bench 2 ask the model to run a stimulated vending machine business for a year and stores it on the financial bank balance. GLM5 finishes it with this first among the top Opus 4.6 4.5s. Okay. is the team's internal audit of front-end benchmark and long horizon coding task. GLM5 substantially beats GLM 4.7 and narrows the gap to over 4.5. Through line of all four-figure and open weight model is nearly competitive with frontier proprietary, especially on real long agentic coding work. The training pipeline at a glance. Every later chapter slots into one box of this pipeline. Internalize it now, okay? So there's a base model which is pre-training, general language plus code, 27 trillion token, code and reasoning heavy, MOE architecture, MLA to DSA, okay? Mid training, agentic plus long context, extend context from 32 to 128 to 200K, software engineering and long doc data. Post training, SFT reasoning RL, agentic RL, general RL, interleaved thinking, okay, math, science or code, code and research. Mhm. On policy, cross stage distillation, final step prevents forgetting. Uh, Deployment inference. Hmm. Chinese chip adoption. That is a big thing. It teaches a raw language and coding ability from about 27 trillion token corpus. Chapter 6. Mid training sketches the model's usable context window from 4K to 200K token and injects agentic and long document data. Post training is a sequence of reinforcement learning stages, each sharpening a different capability capped by a distillation step that stitches the gains together without losing earlier skills. Deployment is the efficiency trick quantization custom kernel, the 1 million token context of GLM 5.2 make the training model uh, practical to run. If you remember nothing else, remember this shape: base, post train RL sequence, deployment. Everything technical hangs off it. The four technical contribution. The paper distilled its novelty into four claims. Each gets full chapter later. Here is one sentence version of each with frontier pointer. DSA plus skill. GLM5 adopts DeepSeek sparse attention while dynamically allocates attention to only the important token, slashing the compute cost of long context. This efficiency is what lets the team scale from 744 billion parameter and 28.5 trillion training token without the cost exploding. Okay. Asynchronous RL infrastructure. This builds a new training system, extends their open framework slime that decouple generation from training. The GPUs that generate agent trajectory and GPUs that update the model run independently. So neither sits idle waiting for the other. This is the system breakthrough that makes large scale agent training fast enough to iterate on. Novel asynchronous agent RL algorithm. New learning algorithm, a token in token out gateway, a double slide importance scheme of policy space filtering that keeps training stable since even though trajectories are generated asynchronously by slightly stale versions of the model. Day 1 Chinese chip adoption. From release, GLM 5 runs full stack. From low level kernel up to the inference engine on 7 domestic chip provider. Oh, reducing dependence on foreign hardware. That's interesting. How this book is organized, why it matters. Three reasons recur. First, efficiency as first class goal. The paper reportedly argues that the path to better AI is not only more parameters but more intelligence per flop. And DSA plus the RL infrastructure are bets on that thesis. Second, one weight, open weight parity. GLM5 is the evidence that openly released model can sit at the frontier, which changes who gets to build on top of them. Third, agentic reliability. The move from benchmark chasing to can it actually run an end to end engineering task for us reframes what we should measure. So, chapter 1 and 2 is about architecture, 3 to 7 is about architectural data, mid training infra. Okay, post training is SFT, RL stages, distillation slime. Okay, then we have agentic engineering, the environments. Mhm. Systems and deployment, which is Chinese chip, evaluation, benchmark real world, and reflection and references appendix. Each chapter explains the work it cites in line. Where GLM5 says we adopt GRPO, we will pause and explain what GRPO is, what its paper contribute, and why GLM5 reaches for it. That way, the 63 entry reference list becomes a guided tool rather than a wall of citation. So, what are the takeaway from chapter 1? Vibe coding, agentic engineering is the move from human in the loop autocomplete to AI that plans, implement, and self correct over long horizon tasks. Arc, which is agent reasoning and coding, bundles in into one model because they reinforce each other at the risk of catastrophic forgetting, which post training fights. GLM5 OpenWeight MOE 744 billion total, 40 billion active. DSA attention 28.5 trillion training token. GLM 5.2 adds 1 million token context via index share. Okay. The results claim open weight parity with proprietary frontier, especially on long horizon agentic coding. The pipeline is base, pre plus mid training, post training RL sequence, deployment, and the four contributions are DSA, scale, async RL infra, async agent RL algorithm, Chinese chip adoption, where we open up the mixture of expert architecture, the attention mechanism, and the specific scaling choices that define GLM5's body before any sparsity or RL is added. Okay, so I hope you enjoyed it.